You can talk to them.
Macam.
The student has a mic, then you talk to him. The student must pass the mic.
Where's the boss?
Student want to go. Okay, wait. Wait. Okay, almost there. I take the link. No. I know. Okay, no. Professor, your WhatsApp.
Yes.
Come. Where's the WhatsApp?
You cannot disrupt, right? You help me post
No, you post.
Post
Very fast one. You just put a rapid one. Is it okay?
Yeah.
Lesson delay, never mind one. Who's who can stop for you? Just delay. Then we just put them together. Wait. Your WhatsApp is not up yet. Wait.
Boss, you go WhatsApp on your phone. It'll be faster.
No, I need to get the.
Mask.
One very facial.
I don't like it.
I don't like. That's the thing.
No, I cover my face better.
Cover your face
Yeah,
better, right?
it's stable.
That's all.
Send already. Wait, we test again. Okay, good. Stand up.
Now all the way keep silent.
That means
What does pH stand for?
potential of hydrogen. Yeah, I won't test you things that you don't know. Don't worry lah. Is that Louis? We haven't sent the link yet.
So then, routine to check OAC that. That's be natural. Only thing is, only thing is when you asked to talk, right? Wait for the mic to pass to you. There are two mic. One of the teacher, Mr. Eugene is holding one. Where's the second mic? Yeah. So the whoever will stand up, just relax for the mic to pass. I mean, from students to student. Until the mic comes, then around here, just talk normally. Understand? The rest is as per normal. No need to act. We are not actors. We are teachers and students here. Okay, clear? Okay, good luck.
The higher the pH, the more oxygen what does pH stand for?
Mr. Till, the voice, the sound works, right?
The only tables. Look at how close it is. Surely periodic table.
The members, right? There's an entire list. Entire list of and grouping the list. So anything you don't have to do about the
Okay.
so for now, we just need to as we reach like then actually we'll extend more on this.
Is there actual computers in banana?
There are probably items. So actually, we're going to like
Good morning, students. Let us come together as one message for the morning prayer. I would like to invite everyone to pause and use this time to pray with the tradition. Please start with strength your voice and turn to page 13. Today, I say the prayer followed by Jesus, followed by the Hail Mary. Let us remember that we are the holy presence of God. In the name of the Father, and the Son, and the Holy Spirit. Lord, thank you for giving us a pure mind that can believe and a peaceful heart that can love. Help us to keep learning every day, no matter what the subjects may be. Encourage us when the subject seems difficult and we are tempted to give up. Grant us the grace to put our knowledge to good use in building the kingdom of God on earth. Through Jesus Christ, our Lord. Hail Mary, full of grace, the Lord is with thee. Blessed art thou amongst women, and blessed is the fruit of thy womb, Jesus. Holy Mary, Mother of God, pray for us sinners, now and at the hour of our death. Amen. In the name of the Father, and of the Son, and of the Holy Spirit.
Check that they use the word every single guy they look at.
okay, teacher's mic testing 1, 2, 3. Why no hair? The hair chopped off. Sort of aging mic. Does this mic look familiar? Is Sneaky Sushi? Student mic 1, 2, 3 testing. Hey, class 10. Okay, good morning, class. Sit down. Okay, I'm sure you already did your homework. I also checked yesterday. So everyone already did their homework at home. So what we are going to do today is we are going to start on the new chapter, acids and bases. Okay? Now, but before we even anything, let's have a short challenge to put ourselves up since it's like 8 a.m. in the morning and we're like half asleep. So can I have 2 volunteers for something called the Big Brand Challenge? Around one guy and one girl now. Okay, come, Jitro. Hey, come here, come here. There's a space for you. And then there's my girl, right? Who? Anyone wants to volunteer? If you want to volunteer, I have a number in mind. This is February number 2. Okay, there's a space for you, don't worry. So what's gonna happen for this big breath challenge? I give you what you all have first, okay? Everyone holds this. And then Jicho holds this as well. Hold it by the neck now. So everyone can see what's below. Okay, so the rules are simple. I'm gonna give you this straw. Donated with the courtesy of Koi. So it's individually packed, don't very hygienic. Okay, so what you do is you blow into the straw, right? And okay, the first person to make the straw, the solution turn yellow will win. Okay, so you take out the plastic first. Hey, Jicho, you is it? Okay, most importantly, when you see what Jicho is saying there, is don't drink, you have to blow, not the other way, don't suck the liquid, okay? Okay, but while they are doing this, while you are watching this, what you have to do is you have to cheer them on, but we also need you to think a little bit, okay? Think of what actually makes up the solution. What is actually inside it? So actually, if you look at it now, what color is it? It's purple, right? Okay, I know the people behind can't see them very clearly, so let me change my screen. Oh, now you can see them. Okay, now we all put a straw in. I remind you all one more time, okay? Don't drink it. You are supposed to only blow. Okay, ready? And you can take out your mask. Okay, 3. Julian, what are you waiting for? 3. Hey, Julian, face the camera. 3, 2, 1, go! Don't be so excited. Hey, Jicho, slow down, Jicho, don't worry. Jicho, you look like you're losing, Jicho. Jillian! Hold it straight, then you won't steal. Okay, if you can see carefully, see Jicho's and Jillian. Almost there. Yellow already. Okay, let me give you a towel. Okay, I don't know how you blow until your entire hands are wet. Jicho, do you drink it? Alright. Don't scare me. Okay. Okay, can round of applause for Jicho. Oh, you can go back. Thank you. Jicho, I'll give you a prize next lesson, okay? Hey, why? You didn't volunteer, then now you come in there. Now, you had a short, a small job to do while you're watching. So, I give you like another 3 seconds or so to think about what you actually saw and what do you think is actually inside the solution. Okay? Think a little bit. What you learned before is mostly linked to things that you have learned to do and during the classroom that you learned, the slides that you saw. Okay? I'll give you a clue. There are 3 things. I'll have Jim to answer. Jim, come, stand up. Okay, Jim, I'll guide you along, okay, so that it's not too scary. First one. The first one is simple. What is the solvent that's inside the solution? What's the main thing? Not lime water. Main bulk of it. What do we usually put as a solvent? What do we normally dissolve things in? Okay, the first one is water. It's quite straightforward. The first thing is water. Now, what makes it so magical was that it changed color. What solution did we learn before that has the ability to change color? Very good. Universal indicator. We are almost there. Now, at the start of the experiment, that the color of the solution was purple. What caused it to appear blue or purple initially?
I'll say the alpha.
Good. Thank you, Jin. Sit down. So the reason why it appeared blue or purple initially was because there was an alkali. In this case, specifically the alkali that we use was sodium hydroxide. Okay, so this is quite a strong base. That's why I asked you to don't drink it. Okay, so the next question is this. What do you think caused the solution to turn red eventually or turn yellow eventually in this case? Why after blowing up for a while it actually turns yellow? Hakim, let me pass your mic so people can hear you. Hold it up to your mouth. Okay, Hakim, what do you think?
For me, like their saliva, because it's like acid.
Saliva! But the saliva didn't come into contact with the solution. Okay, think about what they were doing.
Blowing.
They were?
Blowing.
So what was inside the exhaled gas that they were?
Carbon dioxide.
Carbon dioxide. Now, just to push it a little bit, just to think a little bit more, if it is changing from blue to yellow, what does that actually tell you about carbon dioxide?
It's like acidic.
Awesome. Thank you so much, Hakim. Can I have my mic? Okay, so what actually happened was our exhaled breath, we know that it contains a large amount of carbon dioxide. Now, carbon dioxide is actually what we call an acidic oxide. Now, why is this important? I think a very common misconception that a lot of us have is, if it is an acid, the name must be something acid. But that's not true. There are other substances that are acidic as well. Now, why is carbon dioxide acidic? Can anyone tell me? Anyone has any clue? Yes, Chicho. You understand up?
It has hydrogen.
It has
It has negative
nitrogen,
hydrogen.
hydrogen, okay? We know that acid substances must have hydrogen ions, right? But if you look at carbon dioxide, the formula for carbon dioxide is CO2. So where did the hydrogen actually come from? Okay, so what happens is, when carbon dioxide dissolves in water, it actually forms what we call H2CO3. And this is carbonic acid. Now, why is this experiment important? This experiment is very useful because it allows me to actually introduce you to all the things that we're going to learn in this chapter. So what's actually in this chapter? You have covered a little bit about acids already. Next, we are going to move on to bases and alkalis. In Sec 2 lower sec science, right, we mostly focus on alkalis. But alkali is actually a type of base. And what exactly is that? We'll come to that when we finish acid lah. Next thing, we will learn about indicators. And the fourth one is something that's totally new. How do we interpret a titration curve? Now this is probably like the trickiest part of this chapter. But don't worry, when we get there, I'll help you through it lah. And lastly, we learn about the different types of oxides. So you learn in our bonding chapter, you learn like sodium oxide, magnesium oxide, carbon dioxide, sulfur trioxide, many different types of oxides. All these oxides actually have a different nature. Some of them can be basic, some of them can be acidic, some of them can be neutral, and something new, some of them can be amphoteric as well. Okay? If that word confuses you because it's a big word, don't worry. We will also cover it when we get there. But today, just today, we're just going to focus on acids. So the first two parts of acid, which is the definitions of acid and the different properties of an acid, you already did it on your own. When I talk about properties, we talk about both physical and chemical properties, of course. Okay. Then the next thing that we have to cover is actually the difference between strength and concentration of an acid. But we're not going to do that today. Okay. What we're going to do today is actually to think about how acids are actually very relevant in our everyday life. But before we can even do that, let's address some of the mistakes that you all made in your small piece yesterday. So let's pull out the quiz. Actually, for this quiz, I want to commend two people, Shi Kai and Edward. Why do I want to commend them? Because as I was looking at this quiz, I was thinking, why are there 47 responses? So I was just wondering why. Now I realized that Shi Kai and Edward, the first time they did it, they got like 0 and 1. Probably didn't study, you're just going to work the quiz, right? Yeah, so I realized that after they did the first time that they got it wrong, the second time they all got like 4 marks and 5 marks, so they probably went to study after that. Okay, so very importantly, if I give you a set of content to study, please study properly before you actually go and attempt the quiz. But I still commend them because they did take the effort to retry to get a better score. Okay, so let's look at the questions. Now the first question was quite straightforward. Most of us got it right, 41 students. Actually, that's the whole class. So let's move on to the next one. Which of the following is produced by all acids? Now I realize that there's quite a sizable number of you that wrote hydrogen atom. Now can someone remind me what's the difference between an atom and an ion? Anyone? You all should know this. Yes, Jim. Stand up. Okay, how many pass to Jim?
Atom has the same number of protons and electrons.
Okay, protons is the same as the number of electrons and
Different number of protons.
okay, simply put, protons and electrons are not equal number. Thanks so much. Thanks much, Jim. Okay, but more importantly, right, you realize that when it comes to atom, there is no charge as well, and when it comes to ions, there is a charge. So when we talk about acids, right, let me just blank out the screen so I can use the whiteboard. Oh. So when it comes to acids, right, you realize that the most common acids that we talk about are the big three. The three common inorganic acids are nitric acid, sulfuric acid, and hydrochloric acid. Now, in case you ever forget the formula, right, you should know that what's the formula of a nitrate ion? NO3 minus. So in order to make it neutral, right, how many H plus do I need? 1. Okay, next, when I talk about sulfuric acid, it contains sulfate ions. It has a charge of 2 minus. So how many H plus do I need to neutralize that charge? 2H plus. So that's why the formula for sulfuric acid is H2SO4 instead of just HSO4. And lastly, for hydrochloric acid, chlorine is in group 7. So what's the charge of my chloride ion? Cl? Minus. Very good. And then, in order to neutralize the charge, how many H plus do I need? 1. That's why it's just HCl, not H2Cl, not H3Cl. It's just HCl. Just to make sure that we understand how that works. Phosphoric acid contains phosphate, which is PO4 3 minus. So what do you think the formula of phosphoric acid is? H3PO4. Excellent. Okay, to ensure that we can neutralize the 3 minus charge, we require a total of 3H plus ions as well. Okay, so why do I write this out? This actually for us to better understand. When it comes to acids, they all produce H plus, and H plus has a charge. Given that it has a charge, is it an ion or is it an atom? It is an ion. Okay, so all acids produce H plus ions. Now, let's get my screen back up. I think the more worrying question wasn't this, the more worrying question was this. Which of the following can be classified as a base? Now you realize that there's a lot of people who got it wrong. But I did foresee this because when we are in lower set, we don't really talk about bases, we always talk about alkalis. So what's the difference between base and alkali? Does anyone know by any chance? You know? You know? But you're my star student, you know?
Yeah, that's the thing.
Okay, so bases and alkalis are very similar. Like I said just now, alkalis are a special type of base. Let's clean this up. We're skipping a little bit here, okay? This is actually covered in the next part. But just to make sure that we are not lost when we talk about reactions, when we talk about bases, all metal oxides or hydroxides are considered as bases. So when we talk about magnesium oxide, magnesium hydroxide, aluminum oxide, and hydroxide, sodium oxide, iron trioxide, all oxides and all hydroxides are considered as bases. And in the middle of it all, some of them are called alkali. Now what's the difference between an acid and alkali? An alkali is simply a soluble base. What does soluble mean? Are able to dissolve in water. So like for example, if I'm sodium oxide or sodium hydroxide, I am a base. But because sodium oxide can be dissolved in water, then we also call sodium oxide a alkali. Okay? Make sense? Okay. So I think that's all the questions that we have problems with. The last one was the last two were quite well done as well. So let's go back to our lesson. This is the fun part. When we talk about acids in our everyday life, we usually have a lot of negative connotations associated with it. We know that acid causes like acid rain. We know that whenever cartoons draw acid, there's always this skull face figure looking at us. So it's always associated with danger, and it's always associated with like death lah. But is acid always a bad thing? Are there actually acids in our everyday life? In our food, what acid is usually in our food? Lemon is not acid. Lemon contains? Yeah. Okay, so actually, just nice. The first thing I'm going to talk about is actually sour gummies. Now this is my favorite. This was my lifesaver when I was in school. So whenever I was sleepy or like tired, I always will suck on a sour gummy or like chew on a sour gummy. Now first question. What color do you think the universal indicator would be if I take sour power and soak it in water? You know?
Red.
Red? Let's see if you're right, okay? I have sour power here. Okay. You want one?
Yeah.
You don't deserve it yet. Okay. Let's change it to my camera so that we can see it better. Okay. Let me sit down, okay, so that I can adjust this well. Okay. Now, can you all see? Okay, so at least you can see the screen better. Now I have a bigger water here. Oh, I should adjust it a little bit lower. And I have my soft ball. How many should I put in? One, Louis, right? Because anything I don't put, I can give you, right, Louis? I'll put two. I'll leave two. One potentially for Louis and one potentially for Enoch. Okay. Let's put in the first sour power. What a waste, right?
Yeah.
And you can have the one inside the solution later, Enoch.
I don't like it.
Okay, and we're adding one more. I should eat it.
Yeah, you can eat it, just eat it.
Okay, and I have universal indicator here. Let's see if Enoch is right, okay? So, we know that all acids, how do they taste? The physical property. Right, we know that they are sour, right? So, given that sour power is known to be sour, does it contain acid? The answer is? It's pink. Maybe if I add one more sour power, it will actually turn red. The answer actually is correct lah. So actually, this shows that is pretty acidic. Yes, Hakim.
It doesn't like sour candy contain the powder coating on it is called organic acid, right?
Very good. Thank you. So actually, that's the next thing I was going to say. Now, whenever we have sour, the two most common acids that we find in everything that's sour is citric acid and malic acid. Now, of course, if it's an acid, then the pH has to be more or less than 7. More or less than 7. Less than 7, right? And then causes my universal indicator to turn red or pink. Okay? So what is present in sour power is what Hakim has answered. Hakim, because of that, you earn one sour power. Okay? So, then the next question is, so what if it contains citric acid? So what does it So what if it contains malic acid? Why does our tongue taste the taste of sourness? Yeah. So actually this explores a little bit to the biology realm. Yes.
Isn't it like when there's like certain chemicals, right? Your tongue can take it, right? Because certain chemicals. Right?
Okay, let me pass you the mic so people can hear what you're saying. Jillian? Hey, Jillian.
Oh. So citric acid, right, it has like a certain shape. Then your tongue can also like has a shape that matches the shape. Then it can like
Your tongue has a shape that matches the shape. Your tongue playing Lego, is it? Actually, almost there. You're almost there. I think what you're thinking about is the idea of receptors.
yeah.
Okay. Not completely true, but let's explore the idea. Okay. So, what do you think acids have that allows our cell to detect in such a way that we can taste sourness? What do you think all acids? I repeat my question. Okay. What do you think all acids have that allows our cell for our to process it as it being sour?
Hydrogen.
Excellent. Okay. Intelligence.
What sour power?
If I give one to Hakim, I have one more. Okay, sure. So actually, yes.
There's not really like all of it.
Yeah, Louis, you need backup, man, Louis. So I think what we most commonly see on internet is actually what we call a tongue taste map, right? So normally what they like to do is they like to draw a tongue and then tell you like, oh, this part tastes bitter, this part tastes sweet, this part tastes sour, and this part tastes salty. That's something that we commonly see on the internet, but this is not true. It's not that only that portion can taste sweet, that portion can taste sour, that portion can taste salty. Actually, really think about it, it doesn't make sense lah. Because can't be like, can't be so concentrated on a certain area, right? So actually, this is a more accurate like taste map. What you have is actually cells all around your tongue. I'll explain this to the best of my abilities because I only took bio under Sec 2. So you are better bio students than me. But there are certain areas that allows us to taste certain tastes better than others. Like for example, if you talk about bitterness, the area that is closest to the back of your tongue tastes bitter very well because it actually, anything that's bitter is registered as not good for your body, so it forces you to vomit it out. Okay? But when it comes to acid later, the detection of acid actually comes from our H plus ions. That's why it is sour, and that's why acids are sour. The H plus ions actually enters our cell through something called a proton channel. Have you learned biology yet? Okay, so what a proton channel is, in very simple layman terms, is you know that every cell has a cell membrane, right? And you know that a cell membrane is a partially permeable membrane, correct? Now, sometimes inside this cell membrane, there is also a specific tunnel. I shall call it a tunnel to make it look as easily visualizable as possible. This tunnel that specifically only allows H plus to enter. So this H plus that enters a cell, right, causes a difference in like the charge, and it sends a signal to the brain, and the brain registers it as sour. That's a simple layman way that I understand it. I'm sure in 1 year's time you will understand it way better than I do. Okay, but the more important thing that I want to emphasize here is the reason it tastes sour, the reason sweet tastes sour, and our acids taste sour is precisely because of the ion that we know that is characteristic of every single acid. That's why all acids will always taste sour. Make sense so far? Okay, so that's the first experiment. Now the second one is a little bit more close to my heart because I drink Coke almost every day. Until my girlfriend recently scolded me, so I try my best not to drink so much anymore. But when we talk about Coke, right? Coke is actually commonly known to be very, very acidic. It contains what we call phosphoric acid. Now let me show you a very short video about Coke. Let me get a sound cable in. never mind, the sound cable is stuck. Okay, let me just show you this video.
Cleaning up rust doesn't have to be a chore.
Can you
It
hear?
can be fun too. Channel your inner
Basically,
strength.
they have a rusty piece of metal and they're pouring your
Rusted
coke
penny
in.
into a glass of Coke and wait to see what happens. When it comes out, it'll shine like a new penny. Soak other rusted items in a container full of Coke and let them soak
Let me
for
see some of the
24
flat.
hours. If the item is too big to be soaked, pour the Coca-Cola directly onto the sink. You can also soak a sponge in Coke and scrub the rust off with it. If the rust is on a car's bumper or a motorcycle, soaking a piece of crumpled aluminum foil in Coke and scrubbing the bumper with it can work wonders. If you don't have Coke at home but have other sodas, they might also do the trick. Many sodas have a high content of phosphoric acid and citric acid, which are components that can get rid of rust. Using Coke might be really fun, but be ready for a very sticky situation. You'll need a good amount of water and soap afterward to get the stickiness left by the soda. Make sure that when you're done with any of these methods, you immediately dry all the items.
So I actually cut this video for a much longer video. They actually use many different types of acids to clear rust. But I purposely let it stay in this slide in case there's anyone that is adventurous enough to try to use Coke to remove rust. Please make sure that you always wash them. If not, you're going to be breeding ants in your house. Then your mother will be calling me and say, "Hey, Mr. Eugene, what do you teach my son or daughter?" Yeah. Okay. Now, let's think about it. Why is Coke able to remove rust? Manfred. I'll help you, okay? What do you think? Oxidation. Is it oxidation? It's not. But we are somewhere along the way. Why do I say we're somewhere along the way? Let me help you. Coke. It removes rust. Okay. Now, can you tell me the three reactions that this undergo? Okay, given that acids react with carbonates, react with metals, react with bases, rust must be one of them. That's why it's able to be removed by undergoing a chemical reaction. Make sense so far, Manfred? Okay, let's think a little bit about what you just said. You said oxidation. What undergoes oxidation to form what? Okay, what do you think? Why would you say oxidation?
Cause metal plus
We're almost there. Metal.
oxygen plus water vapor.
Okay, let's write it out in words first, okay? So metal plus oxygen plus water vapor, I get
Rust.
rust. Very good, Manfred. We're almost there.
Also the acid react with metal.
So if I'm rust, right? Am I still a metal? Given that I've already reacted with oxygen and cannot be, right? So I know that I'm not a metal. So what do you think this is? It makes with oxygen. This is my biggest clue to you.
Base.
Very good. So, thanks, Manfred. You can sit down. Next lesson, I'll pass it to you. Okay. Cannot eat. You can keep it inside a frame, then see that like this was for answering a question during class. So what type of reaction is this? Acid plus base is what? What's the name of the reaction? Neutralization. Very good. So this is actually a very simple neutralization reaction. So how do we know that? Because actually rust has a formula that is Fe2O3. The dot 3H2O, you all know that it's water of crystallization lah. But let's ignore it for now. When it is Fe2O3, let's get the basics right first. What's the name of this substance? Fe2O3. Iron? You know, I heard that. You think about it again. Very good. Now, Fe2O3 is actually known to be, is actually called iron 3 oxide. How do I know it's iron 3 oxide and not what he not initially said, which is iron 2 oxide? Yes, Hatim. What is the cross thingy? Okay, if I crisscross the charge, I'll get Fe3 plus. But more importantly, to neutralize the 2 minus of my oxygen, which has 3, each ion must be 3 plus, and that allows me to get iron 3 oxide. Now, iron 3 oxide is a base, is a metal oxide, and metal oxide is react with acids to form acid plus base gives me salt plus water, and that allows me to remove rust. Does that make more sense now? Yeah, so actually a lot of the simple things that we see in our everyday life, a lot of the things that we do are actually very based in chemical reactions. There are things that you all already know. You all just haven't linked it up yet. Things that are in school are actually very, very commonly found at home. It's just a matter of us applying the correct concepts to the correct things that we're looking at. So Coke actually has many, many uses. I don't know if you know, but it actually can be used to remove stains on shirt. Like for example, wine stains are very hard to remove. Sometimes it can be removed by Coke. Your toilet bowls are actually very, very easily cleanable by Coke as well. And there's many, many more. You all can go and read up about it when the time comes around. Okay? Can you go and try it? You just don't tell your mother that I told you to do it. I just want to state here that I do not endorse any of your experiments at home. Please get clearance from your parents. We want all of you to like breed ants at home. Last one. Make some eggshell. Now actually secondary school in Sec 2, sometimes you have read it somewhere before that eggshell is made out of a certain thing. But if you don't say, okay? Let's watch a very simple demonstration. Now, let's bring out my photo booth. I have an egg here. Can we eat it? Depends. You can decide after the experiment. Okay. And at the same time, I have vinegar. Now, do you know what does vinegar contain? Vinegar contains vinegar. Jim, how do you feel about the things that you just said?
No, I didn't say that.
You didn't say it. Vinegar contains an acid, okay? So let's pour my vinegar into my beaker and let's see what happens. Okay, this is like a $1.50 vinegar. So, okay, let's look very closely. What do you realize is happening on the surface of the eggshell? There are bubbles. Now, we call this effervescence. Whenever there's bubbling, we call it effervescence. So, let's link it to things that we already know. Where's my stuff? Same thing. Egg, acid, when it reacts with eggshell, it produces effervescence. There is bubbles. Manfred has helped us just now. Acids undergo 3 types of reaction with metal, with carbonate, and with bases. So let's think about this one now. What do you think the eggshell is made of? Yes, Ivan. Hold on, let me get the mic to you.
Carbonate.
How do you know it's acid carbonate?
Cause usually the bubbles like carbon.
How do you know it's carbon dioxide you breathe?
Cause carbon dioxide cannot dissolve in organic solvent. I don't know if, but
Okay, the thing is your answer. Okay, I can tell you firstly how is correct, but let's guide you through how you make that conclusion, okay? Now, out of these 3 reactions, right, if I say that there's a gas being produced, which one will I eliminate immediately?
base.
It cannot be an acid with a base, correct? Because there is just salt and water. There isn't a gas being produced. But when it's acid plus metal, I get salt plus
Hydrogen.
hydrogen. And with acid plus carbonate, I get salt plus
Water
plus carbon dioxide. Each of these produces a gas. So I think the only thing that's left is actually to ask yourself, do you think the is made of a metal or do you think it's made of a carbonate?
Carbonate.
Very good. Your reward is you get the half empty vinegar bottle later. Home to your mother, she'll be very happy. And do what? Yes, Hakim. Hey, excellent. Hakim, what's happening to you today? This is such a different Hakim. This is not the Hakim that I know. Okay. Yeah. So, actually, you ask yourself a few simple questions. It actually allows you to draw very clear conclusions about simple things that we see every day. We know that it produces a gas. We know that only 2 of the acid reactions produce a gas. And simply by thinking a little bit about the eggshell, can it even be a metal? No. Then you know that the eggshell must be a carbonate. Now, what color will metal usually be? It will either be grey or not black lah. I mean silver and gold are silver and gold lah. But there's copper. What do you know what color copper is? Have you seen a copper wire? We call it pink or red brown. So whenever we talk about metals, they usually have a certain color. They usually have a certain look. They are normally silver, normally pink, and it's usually a little bit shiny. So by looking at the eggshell, I know for sure that this can't be a metal lah. So eggshell is actually 95% calcium carbonate. But of course, there's other organic metals such as proteins as well. Okay? So actually, what I did right over the weekend, was I actually soaked the entire egg in the vinegar and I left it in my toilet for 2 days. Even though my parents complained a lot, my sister complained a lot, my aunt for the name of science. So because calcium carbonate right reacts with acid, after I soaked it for 2 days, what do you think happens to the eggshell? It reacts away, right? So do you think after 2 days there's still an eggshell? There isn't. So when I remove the entire eggshell, the next thing that we see inside the egg is what we call a membrane. So it actually looks really, really cute. My sister was asking me whether she could touch it. But what you get is eventually you get a very bouncy egg. So if you look at this egg, can you see the egg yolk swimming inside?
Drop it.
Drop it! I will drop it like in a camp, but we're not. So this is a bouncy egg. Why is it a bouncy egg? Because once I reacted away all the carbonate, what I'm left with is actually the membrane. And this is what we are seeing. So it actually is not very safe. But if you look, like if I drop it, I'm quite sure you'll break. But if you go on YouTube, right, what some people have managed to do is they managed to create bouncy eggs that you can drop off on the second floor and it just bounces. It defies any logic completely. But yeah, yes. Drop on the table. Who's going to clean it with my friend? Drop in my container. No, not my niece. Okay. I tell you, I promise you, I'll keep this until the day we go to Chem Lab and then you drop it, okay? And then if it doesn't break, you'll give it to Hakim. Okay, yes.
Can we say the eggshell disintegrates?
Disintegrates. It doesn't disintegrate, it actually reacts away. So if you think in terms of chemistry, right, then calcium carbonate plus your acid will give you a salt plus carbon dioxide plus water, right? And because the salt actually dissolves in water, so that's why it gets removed.
Like dissolves away.
Yes, in that sense, yes. Yeah. Okay. So unfortunately, our time is up. So that's all that we have for today. Now, what I really wanted to bring across today is actually like things that we learn in the textbook, right? Whenever it's about chemistry, it always seems very abstract. It's always about atoms and molecules and ions that we cannot see in our everyday life. But actually, if we look hard enough, right, you realize that actually all these applications of chemistry can easily be found in our house as well. So what we have done today is we have covered definition of an acid and properties of an acid. I hope after today you can better remember your acid reactions so that we can build on this knowledge in the subsequent lessons. Okay? So the next thing that we are going to do is going to talk about strong acid and concentrated acid. So a little bit of homework as well. After today, I'm going to upload 2 simple documents into Google Classroom. One about strong and weak acid, and one on concentrated and dilute acid. So I want you to go home, read those 2 articles, think a little bit about whether or not a strong acid is the same as a concentrated acid. Okay, and then we'll come to class to discuss. Alright? When's our next class? Monday. Oh, just nice. So we have the whole weekend to read it out. Okay? Are there any questions about today? Okay, I'll leave the bouncy egg here. So in case on the way out you want to touch the bouncy egg a little bit, you can. But no, you don't poke it. Don't destroy my bouncy egg. If not, you cannot do the camera. But if there are no questions, then that's all I have for today. Let's do it. That's it. Hey, thank you, Choo Choo.
Thank you, Mr. Eugene, and may God bless you.
Thank you. Bye bye.